Thank you. So yes, I'm going to be talking about internal builds and how we move fast when we're building specifically Android apps. Some of these principles will, especially around dependency inversion, will be beneficial to really any developers, but a lot of this is going to be very Android specific. And I work at IFT, or If This Then That. We build a sort of messaging layer for services that connect to the internet and help you manage your data around that. Also lots of fun automation. So why do we care about internal builds? Why does that help us at all? Does it add complexity? These are a lot of questions that we kind of asked ourselves and asked like product, because of course these things take time. 4 main reasons, sort of 5. Build faster. A lot of times, especially as app developers, we have a server team, and the server team's backlog fills up, and we're blocked as app developers. We depended on that server, our staging server, to work, and right now it's just not feeding us data, and now we can't build our new feature. So with internal builds, what we're going to talk about is dependency inversion and getting that data without needing the server and working on our like production builds. Also, just building faster in general. A lot of times, as app developers on bigger apps, we have some screen really deep in the hierarchy, or like really far back in a backstack, and we make some change, we change some margin, and then we relaunch the app, and then we have to click the screen a million times on our desk to get back to where we were going. We're going to touch on some of the tools or like kind of tricks that we use to immediately be able to navigate faster to where we're going. That like navigation tips that we don't like expose to end users, but are really helpful to us as developers and QA. To force edge cases. This is probably my favorite. You don't want to have to go to, I know I did this a lot as like a very like, when I started off developing, like have to go to my server team and be like, oh, I want to try this edge case. Can you make the staging server return an empty list or something here for a second so I can test it? And that's really crappy and wastes everybody's time. Instead, we can, in our internal builds, just provide options to be able to switch out what we provide in certain screens and what we provide at different layers, like the network layer. Also, what happens when the network is disabled? We don't want to have to go to airplane mode and fiddle with all those things. We don't want to. What happens when the network fails on this certain request and maybe gives me 503 over here? What happens in that combination? Again, with dependency inversion that we'll talk about, really will help expose a lot of those bugs and not force us to like rebuild our app. We'll be able to swap that out a lot at runtime. QAing feature flags. This is one that's been a growing thing for my team personally. We'll build out features in the app, and then we hit our weekly ship date, like we want to ship on a Tuesday, and then like a year ago we used to be like, okay, we'll just comment out the code for the new feature that we don't want to ship, and then it gets to your designer and he's like, okay, well, I want to try out that new feature. I got the latest app on my phone, but how do I play with the new feature we're building this week? And we're like, sorry, it's commented out. With internal builds, you can again expose these features instead of commenting them out. You can expose them, and they can be runtime bound, and we can swap out a Boolean, for example, to simply enable the feature. Similarly with A/B tests, We don't want to, when we ship to QA testers, we don't want them to have inconsistent experiences. They look at your app and they go, okay, why is this color red here and it's blue on my other phone? They want, QA testers need dependable builds. So instead of using, your actual A/B test in production in your internal builds, we'll provide toggleable features and kind of no-op features to get away from A/B tests being unpredictable. And then finally, get actionable feedback from QA. It stinks to get a bug report in and somebody's like, this looks bad on the second screen when I go here and here and here, and you have to read this long bug report. It's great if we can immediately just get a screenshot and development info immediately from your designer or from your QA team, and to be able to get that feedback and be able to immediately like post tickets rather than going back and forth trying to figure out what people mean, and being able and not needing to go get your QA tester's phone and look at the logs manually. So how are we going to do this? 4 big things. The thing that this talk will really rely on is Gradle build flavors. Hopefully, as Android developers, we use Gradle. It's just kind of, as we've moved away from Ant and Maven, this stuff would be really hard to do with Ant. You'd have a lot of configuration files. And so for the talk, I'll assume that most everybody's using Gradle. Dependency inversion. This is not a fancy library. Nothing in this will like require you to use Dagger or anything. As you get more into internal builds, you're going to find Dagger to reduce a lot of boilerplate. But in fact, the app that I primarily work on, when I started on it, didn't have any Dagger in it at all, and it was kind of a process of retrofitting our app to be able to get internal builds without getting Dagger in, and then eventually we moved towards Dagger 2. But again, you don't need any of this fancy knowledge. It's really just about getting your controls farther up in your application's dependency graph. And we're going to talk about some amazing libraries that we use in internal builds, and kind of what we do to no-op things in production builds. And then lastly, you actually want to ship this stuff, so we're going to talk about the Google Play's private listing. Gradle has build types and product flavors. Most people are pretty familiar with build types. You typically have a debug and a release, and you sign your release with your key. Product flavors are really where you're going to put a lot of your features. Excuse me. And here's a very simple example. In a very simple app, you might have internal and production. You can continually add more product flavors on top of each other. I'm going to talk about that in a second. But yeah, so these are very simple examples. What's important here that I want to draw out is do use separate package names for internal and production apps. Otherwise, you're not going to be able to publish to separate listings on Google Play. And then or even if you're not going to ship it to Google Play, if you ship it to somewhere else or something, you don't want your internal users needing to uninstall the production app to be able to install the internal app. You want to have it side by side so that they can test out your nightly builds, and then they can always refer back to what's in production right now. This is kind of the sample source sets for that last slide. What would come out of that? Super simple. You have internal. This is just kind of showing you the cross products. Main is always your main source set. And what I was saying is you can continually add more product flavors. This is kind of a rare thing. So you could have and they would just continually add on to the cross products here. So you could have a free production debug and a paid production debug, et cetera, and you can keep on exponentially growing your trees here. Oh, I do want to mention the Android Studio plugin. The Gradle Android plugin will merge XML resources here. So if you do have your layout, say a separate layout in internal, it will override and it's named the same thing. So you have like home layout in internal, and in main you also have home layout. Internal will override. The most specific will always override the more general. So internal debug will override internal, will override main. For actual, of course, Java source sets, Kotlin source sets, your code source sets, anything that's not a resource or the manifest, that won't override. So if you have foo.java in main and foo.java in internal, when you're trying to build internal, you're going to get the duplicate class, and that'll fail. So you will need to separate out your foo.java, your actual Java source sets into production, internal, etc. So that's the default source sets. You can always override these, of course. You can have multiple directories for any Java, Kotlin, etc. source sets. For resources, also you can have multiple directories. So that's the default. That's an array, so you can just keep on appending to the array. The manifest, of course, you can only have one manifest, and you can specify that. But the default locations, I've never seen a use case where really it's needed to be overridden. Just basic syntax. Probably everybody's aware, but this is just the syntax for adding any dependency in your build file. You have internal compile, production compile. Also, with more cross products, you keep on appending. Similarly, you have internal debug compile, free internal debug compile, and on and on. This is sort of what my finding and my current opinion is. Build types are really good for just signing and leave everything else to product flavors. In my own experience, I've put a lot of things in debug and release build types rather than in production and internal product flavors. And the main problem is when you want to use the debugger, and suddenly everything you put in release, like I put I put like some logging or something in my release variant, and now I can't step through it on the debugger because it's in the release variant, not the debug variant. So those are great stuff to move over to just product flavors. And so in all new code now, I leave the build types for the actual signatures, and product flavors are for any actual code changes and features. So now a little bit touching on how we're actually going to implement this. A precursor, we want to add controls for these behaviors. Like I said, we'll want a menu to be able to swap out these features and behaviors at runtime. So indirection, just dependency, this is just basic indirection. We want to extract out our logic, and in Java we just use interfaces for this. So in a very simple example, everybody knows we want to extract out our tweeter, and then this is going to serve us in our internal builds. We can add more features into this, and we can basically, as we go down the graph, we want to be able to provide fakes and tracing. So in our internal builds, maybe we just for a contrived example, we add in something else to our tweeter. And this is just the basics of any indirection sample and providing fakes downstream. So where this is going to get interesting is when we actually want to provide a UI for this. So in this simple class, a debug view, it could be a view, it could be a controller, it could be a fragment, anything, it could be an activity, anything in between. And we want, this is kind of the model for where we want to get. We want to get our controller to have, in this case, a view. We want to be able to just add these features and then just be able to swap them out at runtime. And then, and in this case of a logging tweeter, suddenly we just flip a switch and now it's logging, and we flip a switch back and then now it's not logging. So we want to introduce kind of this dependency inversion, and this is just getting our control back higher up in our application graph. Instead of, for when we're going to use the tweeter, we don't want to have like new tweeter in the constructor or when we're going to use it. We want to pull these things back up so that we can control them in more places. Gregory Kick kind of called dependency injection. Dependency injection is more like zero argument factory methods for every type, in that we'll have this abstraction where our actual factories live in a centralized place, and we can then pass them, it's just passing things in. We just pass them down in our application graph rather than creating them lower in the graph where they're much harder to control at runtime. So pushing behavior down in Android and kind of just dependency injection and dependency injection in general is kind of hard, as anybody who's worked on Android has noticed, because we don't create a lot of the objects that we actually use. We don't have control over the constructors. So this is most notably like in your activity. We don't have control of the constructor, so we have to grab our application. Basically, our application is injected in our activity, and then we pull out our component. Then we pull out the services that we use. This is a lot of what we use are for scoping is views, just for the sake of continuing, because activities and their life cycles get much more complex. It's much easier to think about views. But views we also create with reflection a lot of times because we like layout XMLs, and the layout inflator is super handy. So there's this kind of hack or trick that has come about that a lot of people, including myself, really like using, and that's this hook on context called get system service. It's where you get your layout inflator, it's where you get your notification manager, it's where you get all of these system services, but you can hack it to get your own services too. So your context is injected into every view that's created with your layout inflator. So you just want to get these services, you just want to start pulling them off of the context. So what we tend to do is extend a context wrapper, and then we give it, we basically have that provide a separate layout inflator so that we can, every time we inflate something with this context, it has our service that we've passed in available to whatever's using this layout inflator. And the views inflated with it can then grab our service here. Adding controls for behavior. This is another part where a lot of inversion is very, very handy. The abstraction that I like to use is kind of a view factory or a view container. And we create the view and we just provide separate layouts. And then we can separate out a lot of different behaviors in this view factory. A little bit later, we'll see a tiny bit of complexity that we add to these view factories that'll make it much more clear why we can't just swap out the XML, and why view factories are a really handy abstraction, and why we can just pass these things through. So this is really this gets into what does the actual UI look like? Where do we provide this menu? There's a lot of possibilities for apps that maybe your layout has gotten very, very complex or something, and it would be difficult to refactor. A very good use case is always just have a separate debug activity. You know, just throw it in your manifest for your so in internal, you just throw it into your internal Android manifest, have that merged with your main manifest, and then you have a debug activity, and you can swap out things. That's a little bit, if you can avoid it, it's great, because there's an even better solution that many have started using in the past few years, and that's actually a drawer, hacking kind of the drawer layout, so that we can always have this menu readily available. There's a quick note I want to make on this. It's not to talk about window insets, but you want to make sure that anything you add in your drawer layout that's consuming the window insets, you want to make sure it's not consuming the insets, because then it's going to actually affect your view hierarchy in your app. So there's a quick trick just to make sure you don't consume the insets. Add that warning. Here's basically what where we want to get. This is an example from a few months ago in our app in IFT. There we can see some really basic toggles, some navigation elements, little bits of extra information that makes it handy for debugging. I like to put in the latest git commit SHA, so we always know which build you are actually on when we ask, okay, where did you see this behavior? And so this is kind of where we want to get, just to provide that idea. And this is very handy because you don't have to leave the app. You have this menu, and you can always just swipe from the right and get there. It's not some kind of it's not kind of a blocking UI for your testers. So practical usage. We kind of saw the silly tweeter example. And like, okay, when do we really want to log things? So I'm going to get into some of the more practical examples where these internal builds really provide a lot of power. So I mentioned A/B tests. This is really great because again, you can just have toggles for swapping out these A/B tests. And rather than hoping that you get in or forcing your A/B test framework to get you or your tester into an A/B experiment, you can just have toggles. So again, kind of with the structure or like with the baseline of the tweeter example, we just provide simple getters and setters, and you can swap these things out at runtime. This is kind of like what our Firebase example might look like, and the really nice thing about having Gradle and having internal flavors is a lot of this stuff you can take and you can apply it. You can apply it with Ant. You can apply it with Maven. You can apply it with other build systems, and then you could just provide these features in some other menu, but we're not actually shipping this code. Like we have this kind of no-op A/B test provider, and there's no risk of this we accidentally forget to flip a flag or something. It's just it only lives in our internal source sets. So there's no risk of ever exposing our debug drawer to end users because it just doesn't live there, and we kind of we live in that straitjacket, making sure that nothing, where you don't have to remember to flip flags when we're going to ship to production, etc. We're going to talk about some really handy libraries that make debugging or make internal builds very easy to navigate and to build out. RX preferences, or really any shared preferences wrapper, is super handy for not just internal builds but also testing. Anywhere, a lot of the tooling that we use is simply for providing fakes downstream and down in our application graph, rather than the real thing, especially when this gets to disk persistence, like shared preferences or a database. If we're using shared preferences everywhere, then it's on the disk, and then in our debug menu, then we need to have different options for clearing the disk and such. This is especially handy when you have welcome screens, anywhere where you really use shared preferences for simple key value pairs. But when you have a welcome screen and then it's provided on the disk, and then you have to go clear when you don't have the benefit of internal builds, you have to go clear your data, and then you have to log out, and you have to go through your welcome screens again. If you have a shared preferences wrapper, again, we really like interfaces. We like being able to provide fakes. We can just provide fake preferences in our internal builds, and we can just swap out those values. We can say, oh, have we already seen the welcome screen? And we just swap that switch and say no. We can always return false for our Boolean preference. So RX preferences, I'm not really talking about the RX part, but this will work for any shared preferences wrapper, any key value store wrapper. Retrofit, most Android developers hopefully are familiar. Retrofit's design pattern that it encourages is using interfaces for your services. So you don't have concrete, again, we really like interfaces for providing fakes downstream. So there's this really handy artifact on the Retrofit repository called Retrofit mock. And here we have, my favorite is really the calls, which we can provide fake calls. The call is just an interface. So if you're using call for your default call adapter in Retrofit, then you can just provide a fake call that will throttle the network. It can provide dummies. This is where I said it's really handy to just get this empty list for empty state. You can affect anything about the call. You could say what happens when it just cancels mid-flight. What happens when the network's flaky. Also, Retrofit mock provides things like network behavior and a lot of these higher level abstractions that you don't have to deal with at kind of the OKHTP interceptor level, just dealing with it right at the Retrofit level. So there are things that are handy to use at the OKHTP interceptor level. My favorites do tend to be network throttling and just canceling the network. OKHTP is really, really powerful because it is really just interceptors all the way down. So we can really mock out anything or fake anything about OKHTP and its behavior in our apps by just providing mutable interceptors. And so when we're creating our OKHTP at the client, probably at the top of our application graph or wherever, then we just install these interceptors onto our internal builds, and then in our internal builds we just pass them on to our debug view, and we can just mutate them from there. So my favorite does tend to be just simply, or like a really simple example is just canceling the network. What happens? I don't have to go to airplane mode. I can just see what happens when all of a sudden my requests stop. Similarly simple for just throttling, just thread.sleep. The OKHTP logging interceptor, also very handy. We also throw these onto our internal builds. Without providing internal builds, we used to have to like tell our server teams, and they wanted to look at something on our app. We had to say, okay, here's how you get Charles Proxy installed, and here's how you set it up on your phone and such. And that's kind of a big roadblock, or kind of a waste of time for a lot of people. Simply, the OKHTTP logging interceptor is pretty simple. You can also customize it very simply to your own needs, but by default, it just prints to logcat, and then your server team or your QA testers say, oh, why am I getting a 500, or why am I getting a 404 on this call or on this screen, can actually see what happened. Just prints out the request and response bodies. You can also configure it to just do the headers and such, but we do provide request and response bodies for easy debugging there. So that's just the OKHTTP logging interceptor artifact on the OKHTTP repository. Telescope. This is one, and is probably going to be the most beneficial, but maybe the most amount of work. Still not that much amount of work, but Telescope is a very cool tool by Matt Precious that basically, when you hold down on your screen, on your layout, it's just a simple frame layout. So Telescope layout is just simple frame layout that intercepts touch input. So if you hold down your screen with 2 fingers, or you can configure it, etc. But hold down your screen for 2 fingers, and then it will print a screenshot and add lots of debugging info, and then send an email. So you can also configure this with Jira to accept email, to just create a ticket. You can also just have it sent to your Android developer. It also provides a hook called a lens, where you can customize the behavior that it actually sends. So this is kind of where that view factory abstraction helps, where we can provide different setup and different kind of dependencies into our view that we create. So, for example, this is the email device info lens. We can add attachments basically to our resulting email that we send to our Jira ticket. This is just a quick Jiff, just to get an example of what I was saying. Yeah, so you hold down. Super simple, really great for QA, very simple to explain to people, and it's actually much simpler than saying, okay, on Samsung phones you got to push the power button and the home button, and then on Nexus phones you got to hold down volume down and power to take screenshots. You can just take a screenshot and send us your debug info, logs, etc. Leak Canary. For those who aren't familiar with Leak Canary, it's a tool to find memory leaks in Java, in Android applications, Java applications. The short of it is that you tell a ref watcher to watch an object, and then it'll hold a weak reference to that object, and then it'll check after a certain amount of time. Has this been nulled out? And if it hasn't, then it says, okay, this is leaked. Leak Canary is kind of different from some of these in that we don't really provide fakes downstream for the Leak Canary types, because the API is very small. We actually just swap out the source sets. So in internal, so we don't really abstract to interfaces. Like I said, we just have concrete types that we swap out the source sets on. So internal compile, we just provide the real Leak Canary. In production compile, we just provide it no ops. By default, it'll provide you a notification, etc. This is done with an intent service, specifically called, there's a class called display leak service in this part of the public API of Leak Canary, and by default it sends notifications, but you can extend it, and you can do, you could post it to your Slack, you could post it to Jira, etc. And the Leak Canary repository has examples of this that PY has written up that are very handy. And that's good, because a lot of your QA people are going to see the notification and they're going to say, okay, I just swipe away. I don't know what a leak is. And then you don't know about it. It's handy if you can actually send that and create a ticket off of it. A lot of these, like I said, with swapping out source sets, a lot of the libraries are very handy because we don't actually ship the code, and we don't add methods, we don't add bloat, we don't add extra layouts to our actual production app. Leak Canary, though, we do swap out source sets, so we do add a little bit. We add some more methods, but it's extremely small. The no-op has an extremely small footprint. I think it's about 40 methods or so added. So actually publishing. Use Google Play. I highly encourage it, mostly because you can get auto updates. People, if you don't have an auto update system for your distribution method, a lot of your internal users are going to be stuck on a build from months ago, and they're going to say, oh, I don't have that new feature yet, and you're going to say, when's the last time you updated? Google Play will get them those auto updates. So this, there's a link, I'll publish the slides, that steps through all of the, you have to have admin access to be able to have the ability to enable restricted distribution. But once you have this, it's under just your normal pricing and distribution, and on the dev console, and then under restrict distribution. The one kind of caveat is that the account that created the that manages the dev console actually has to be a Google Apps account. So if your company's not using Google Apps, it'll be tougher. You could go create a new Google Play account with a Google Apps account, but you might look into options like Hockey at Microsoft's tool, or Crashlytics actually provides beta services, but it's really handy, again, to be able to have auto updates and be able to have users installing your apps side by side and always staying in the latest version there. So credits, a lot of this was inspired by Matt Precious's Debug Builds New Hope, which I highly encourage checking out. He goes more into Dagger and how we kind of use those no argument constructors and the dependency inversion principles to pass down more configurable builds. And he specifically goes into U2020, which he and Jake worked a lot on a few years ago, which I also very much encourage. Basically, like 95% of what I've learned and how I got into a lot of this was off of conversations and working and playing with U2020 and looking into a lot of how that works. A lot of the only thing with U2020 is, of course, it's based on Dagger 1. A lot of the same principles, of course, still apply to Dagger 2. And the Android Studio team and the Android Gradle plugin team, of course, and all of the open source project creators that I talked about. What's next? I'd really like to see more people pushing Buck. So a lot of, like 100% of this depended on Gradle product flavors. I'd really like to learn a lot more about what people will do as Buck becomes bigger, and how people provide internal builds based on other build systems, but Buck and Bazel too. Thank you.
So we have some time for Q&A. Are there any questions? Okay, so I'll ask. And for me, this seems like this whole debug build concept affects your whole architecture. Doesn't it slow you down?
So it actually, in a lot of ways, it actually doesn't slow us down, just because we provide a lot of these features at a very high level in our application graph. So where we're actually providing the dependencies, like our OKHTTP client, we're adding things onto the interceptor. We don't have distributed code. Whereas without things like without Gradle's product flavors, we'd end up with lots of conditionals in our code, and we had to go, if this is true, if our product flavor is like this, then we have to use this dependency. But providing the kind of the indirection with interfaces and such, we can just create our actual internal dependencies much higher in our application graph, and then pass those down. Where it does get to be more work, I guess similar to like the telescope example, is when we're actually changing out layouts based on our internal builds. And that's kind of where the view factory pattern that I've adopted, and we've adopted at IFT, has kind of eliminated a lot of that complexity. But but changing out layouts does tend to add a little bit more complexity, and that's why most of the stuff we use is just in a single debug drawer.
Thanks.